Good evening. This is the Electric Starman. Tonight, we are drifting. We are following a spindly, gold-plated craft that left a very different Earth nearly 50 years ago. As you listen, Voyager 1 is over 15 billion miles away. At that distance, light itself, the fastest messenger in the universe, takes over 22 hours just to reach it. We often think of space as an empty vacuum, but for Voyager, it is a dense, shifting landscape of plasma, magnetic fields, and cosmic rays. Today, we're going to explore the physics of its departure. We'll look at the heliopause, the invisible boundary where the wind from our sun finally tires out and gives way to the ancient pressure of other stars. We'll talk about the radioisotope thermoelectric generators, the 3 small furnaces of decaying plutonium-238 that provide the warmth and power for its aging brain. And we will sit with the golden record, a copper disc coated in gold, etched with the sounds of rain, crickets, and a mother's first words to her child. It is a journey of radical isolation, but as the signal grows weaker, the science becomes more profound. So close your eyes. We are leaving the solar system now. We start with the disk. It is a circle of refined copper. It measures precisely 12 inches across. On its surface, a layer of gold has been applied through a process of electroplating, atom by atom, creating a shimmering, non-corrosive skin that protects the data within from the caustic environment of deep space. If you were to run a finger along its surface, though no hand will ever touch it again, you would feel the micro grooves. These are not just scratches. They are a physical history of a planet. Consider the jacket that protects this disk. It is made of aluminum, but it is electroplated with an ultra-pure sample of the isotope uranium-238. This was a deliberate choice by the engineers. Uranium-238 has a half-life of 4.468 billion years. It acts as a biological clock, a radioactive ledger. Any advanced civilization that finds this craft will measure the decay of that uranium and know, to the millennium, exactly when this messenger was launched from the third rock. The gold on the disk appears a deep, warm yellow. In the laboratory, this color is the result of relativistic quantum chemistry. Because the electrons in gold atoms move so rapidly, at a significant fraction of the speed of light, their energy levels shift, allowing the metal to absorb blue light and reflect the long-wave reds and yellows we associate with wealth and suns. It is a heavy color, a stable color. It is the color of a promise kept across an ocean of vacuum. Inside the grooves, the information is stored in an analog format. There are pictures encoded in waves. There are sounds. The sound of a kiss. The sound of a heartbeat. The heartbeat was recorded by Anne Druin. To record it, the electrical impulses of her heart were converted into vibrations, which were then pressed into the metal. The physics of this transduction is simple, yet haunting. The needle of a playback device would vibrate in the same pattern as her valves opening and closing. In the silence of the interstellar medium, where the temperature hovers just above absolute zero, the atoms of this gold disk are nearly still. They are locked in a lattice of metallic bonds, holding the memory of a woman's pulse in a state of cryogenic perfection. The disk carries a stylus. It carries instructions written in the language of the universe, hydrogen. The diagram shows the hyperfine transition of a hydrogen atom. It is the most common element in the cosmos. By using the time it takes for a hydrogen electron to flip its spin, the Starman provided a universal clock. A second is not a human second. It is a hydrogen second. This is how we speak to the void. We use the fundamental constants of the vacuum to explain our fleeting presence. The vacuum is not truly empty. It is a field of potential. And within that field, Voyager 1 is a tiny, golden grain of dust, shouting in a voice of etched copper. As the craft moves, the gold disk experiences no friction. There is no air to tarnish it. There is no moisture to oxidize the copper beneath. It is safer in the void than it ever was in the vault. The only danger comes from the occasional micrometeoroid, tiny fragments of prehistoric ice or rock traveling at tens of thousands of miles per hour. When one strikes the hull, it doesn't just dent the metal, it vaporizes on impact, creating a tiny puff of plasma. But the disk is shielded. It waits. It carries the music of the spheres and the greetings of 55 languages, whispered into a microphone in a room that no longer exists, on a planet that is slowly turning beneath a sun that is, itself, merely a mid-sized star in a minor spiral arm of a common galaxy. In 1979, Voyager 1 approached the gravity well of Jupiter. To the sensors of the craft, Jupiter was not just a planet. It was a massive, rotating distortion in the fabric of space-time. The craft was falling. It was accelerating toward the gas giant, drawn in by a gravitational pull that is 2.4 times stronger than that of Earth. As it neared, the colors of the planet began to fill the narrow-angle camera's field of view. The great red spot appeared, a storm 3 times the width of the Earth, a swirling vortex of high-pressure clouds that has raged for at least 350 years. The color of the Great Red Spot is a point of academic debate. It is a deep, brick red, a hue that stands out against the pale creams and tans of the surrounding ammonia clouds. This redness is likely caused by chromophores, complex organic molecules like red phosphorus or sulfur compounds. When the sun's ultraviolet light hits the phosphine and ammonia gas rising from the deep interior, a chemical reaction occurs. The molecules break apart and recombine into these dark, light-absorbing pigments. This is the spectroscopy of a nightmare. The red is a sign of high-altitude chemistry, a suntan on the face of a giant. The craft moved through the magnetosphere, a region of space dominated by Jupiter's magnetic field, which is 14 times stronger than Earth's. As Voyager 1 skirted the edge of the clouds, it entered a zone of intense radiation. This is the Io plasma torus. The moon Io, tortured by Jupiter's gravity, erupts with volcanic sulfur, which is then stripped of its electrons by the planet's magnetic field. This creates a donut-shaped ring of glowing, electrified gas. For a machine, this environment is lethal. High-energy electrons and ions pelt the spacecraft, seeking to penetrate the shielding and flip the bits in its memory. The engineers at the Jet Propulsion Laboratory had wrapped the wiring in black boxes and used tantalum shielding. But Voyager still felt the hum of the Jovian radio emissions. Jupiter is the loudest radio source in the sky, a constant, low-frequency roar caused by cyclotron maser instability. It is the sound of electrons spiraling down magnetic field lines, screaming as they are crushed by the giant's grip. The maneuver was a gravity assist. It is a sophisticated game of orbital billiards. By passing behind Jupiter in its orbit, Voyager 1 stole a tiny fraction of the planet's orbital momentum. Jupiter slowed down by an infinitesimal, unmeasurable amount, and in exchange, Voyager was flung forward, its velocity increasing by thousands of miles per hour. This is the conservation of energy expressed as a cosmic slingshot. The craft felt the pull, the acceleration, the silent tightening of the invisible tether, and then the release. It was ejected into the dark, pointed towards Saturn, leaving the Jovian system behind like a discarded shell. The cameras looked back one last time. They saw the crescent of Jupiter, a thin sliver of light illuminating the turbulent edge of the atmosphere. In that shadow, the Coriolis effect creates smaller white ovals, anticyclonic storms that spin like gears in a clockwork sky. The air there is not air. It is a supercritical fluid of hydrogen and helium. Under the immense pressure, the distinction between gas and liquid vanishes. Deep down, the hydrogen becomes metallic, conducting electricity and generating the very magnetic field that had just tried to destroy the traveler. Voyager 1 moved on, its trajectory a perfect arc calculated years before it ever left the ground. Saturn arrived in the autumn of 1980. If Jupiter was power, Saturn was geometry. The craft approached the ring plane, a vast, flat disk of debris that spans 175,000 miles, but is in places only 30 feet thick. This is the Roche limit in action. Any moon that wanders too close to the planet is torn apart by tidal forces. The gravity on the near side of the moon pulls harder than the gravity on the far side, stretching the rock until it shatters into a billion pieces of ice. The rings are 99% pure water ice. They are bright, reflecting the distant sun with a high spectroscopic albedo. To the human eye, they look like solid tracks on a record. But to Voyager's photo polarimeter, they were a swarm. Each particle, some as small as a grain of sand, others as large as a mountain, follows its own independent orbit. They collide softly, grinding against one another, smoothing their edges. The colors of the rings are subtle: beiges, grays, and soft pinks. These colors are the result of contamination. pure ice is white, but these rings have been salted over eons by microscopic dust from meteoroids and organic tholin molecules. Voyager 1 aimed for a gap. It looked specifically at the Cassini division, a 3,000-mile wide dark band between the two densest rings. This gap is not empty because of a lack of material, but because of orbital resonance. The moon, Mimas, exerts a rhythmic tug on any particle in that zone. Every time a particle in the Cassini division orbits twice, Mimas orbits once. This repeated gravitational nudge eventually clears the lane, pushing the ice into other orbits. It is a gravitational broom sweeping the cathedral floor. The craft passed through the shadows of the rings, and for a moment, the sun vanished. The temperature dropped. The sensors felt the cold of a shadow that has lasted for millions of years. The destination was not just the rings, but the moon Titan. Voyager 1 was directed to fly close to this orange world, the only moon in the solar system with a thick atmosphere. The atmosphere is composed primarily of nitrogen, much like Earth's, but it is choked with a thick, photochemical haze of methane and ethane. Because of this haze, the cameras could not see the surface. They saw only a featureless, tangerine orb. This orange color comes from the Rayleigh scattering of sunlight through the organic smog. Shortwave blue light is scattered away, leaving only the long, tired reds and oranges to reach the lens. It was a moment of profound scientific frustration and beauty. We knew there was liquid methane lakes beneath those clouds, but we could only sense the weight of the air above them. The flyby of Titan changed everything. To get close enough to see the atmosphere, the laws of physics demanded a price. The gravity of Titan bent Voyager's path upward, out of the ecliptic plane, the flat disk where all the planets reside. Voyager 1 was no longer traveling outbound along the level of the solar system. It was headed up toward the North Galactic Pole. It was leaving the neighborhood. There would be no more planets, no more moons, only the long, slow climb into the dark. The silence began to deepen. The cameras were turned off to save power, leaving the craft to see the universe only through its magnetic and plasma sensors. It became a blind monk, feeling its way through the void by the touch of the solar wind. The solar wind is a ghost. It is a stream of charged particles, mostly protons and electrons, ejected from the sun's upper atmosphere, the corona. This wind travels at incredible speeds, often exceeding 1 million miles per hour. For decades, Voyager 1 rode this wind. It was the craft's environment, its atmosphere. But as the distance from the sun increased, the density of this wind began to drop. The pressure weakened. Far out, in the cold margins of the outer system, the solar wind began to feel the pushback from the interstellar medium. This is the termination shock. Imagine a river hitting a wall of still water. The solar wind, which has been traveling at supersonic speeds, suddenly hits a boundary where it can no longer push the interstellar gas aside. At this point, the wind must slow down. It does so abruptly. The kinetic energy of the particles, their energy of motion, is suddenly converted into thermal energy. The wind becomes denser. It becomes hotter. It becomes more turbulent. To the sensors on Voyager 1, this was not a visual event, but a physical transition. The low-energy charged particle instrument began to detect a chaotic swirling. The smooth, outbound flow was gone, replaced by a subsonic sludge of particles. The color of this transition, if we could see it, would be a faint, ultraviolet glow. This is caused by the interaction of the neutral hydrogen atoms from the galaxy with the protons of the solar wind. Through a process called charge exchange, a solar proton steals an electron from a galactic hydrogen atom. The result is a neutral atom that flies off into space, and a newly created ion that is picked up by the magnetic field. This creates a glow in the Li-alpha line of the spectrum. It is a soft, bruised light, invisible to the eye but heavy with the weight of the galaxy. The craft felt the bump of the shock. It was moving through a region where the sun was no longer the master, but a tired king retreating to his castle. This slowing down is a requirement of fluid dynamics. In the vacuum of space, the solar wind behaves like a fluid. It obeys the laws of pressure and resistance. At the termination shock, the wind is compressed. The magnetic field lines, which were once straight and clean, become tangled and messy. They loop back on themselves. Voyager 1 moved through this magnetic foam, a region of space where the very fabric of the sun's influence was being shredded by the pressure of the stars that lie beyond. It was the first time a human-made object felt the true weight of the Milky Way. The transition took time. The shock is not a thin line. It is a region of space millions of miles thick. Voyager 1 crossed it in 2004. It was 94 astronomical units from the Sun. At that distance, the Sun is just a very bright star, providing no warmth, only a faint, directional light. The craft was now in the helio sheath. The wind here is slow. It is thick. It is the waiting room before the final exit. For 8 years, Voyager 1 drifted through the helio sheath. It was looking for a ghost. It was looking for the heliopause. This is the final frontier. It is the place where the solar wind stops entirely. It is the edge of the Sun's magnetic bubble. On one side, you have the plasma of our home star. On the other side, you have the ancient, cold plasma of the interstellar medium, gas that was forged in the hearts of stars that died billions of years before our sun was even a cloud of dust. The physics of this boundary is defined by magnetic pressure. The sun has a magnetic field that it carries with it through space. The galaxy also has a magnetic field. Usually these two fields do not mix. They push against each other like two magnets held north to north. As Voyager 1 approached the boundary, the solar wind began to move sideways, diverted by the invisible wall of the interstellar medium. The craft felt a stagnation. The speed of the wind dropped to 0. It was a moment of profound cosmic stillness. The craft was suspended in a transition zone where the influences of home and away were perfectly balanced. On On August 25th, 2012, the sensors reported a sudden, sharp change. The density of the plasma, the number of charged particles per cubic centimeter, suddenly jumped by a factor of 40. At the same time, the number of low-energy particles from the sun plummeted. Voyager 1 had crossed the heliopause. It was no longer in the solar system. It was in interstellar space. The plasma here is different. It is colder. It is much denser. It is made of the debris of 1,000 supernova. The craft was now being guided by the magnetic currents of the galaxy itself. The color of interstellar space is dictated by Lyman alpha radiation. To a human eye, it is absolute blackness, but to a spectrometer, it is filled with the faint, persistent light of distant stars being scattered by neutral hydrogen. This scattering is a fundamental property of the universe's background. It is a cold, blue-white resonance. Voyager 1 is now a deep-sea diver who has finally left the warm, shallow waters of a tropical island and entered the crushing, freezing abyss of the open ocean. There is no more sun wind to push it. There is only the slow, steady pressure of the galactic tide. The craft is now experiencing cosmic rays in their pure, unshielded form. These are high-speed nuclei, mostly hydrogen and helium, traveling at nearly the speed of light. Inside the sun's bubble, we are protected from most of these rays. But out here, Voyager 1 is being sandblasted by the raw energy of the cosmos. Each strike on the hull is a tiny, invisible explosion. Voyager measures these strikes. They are the heartbeat of the galaxy. They tell us about the high energy events happening in distant nebula. The craft is no longer just a messenger. It has become a witness to the true nature of the void. The interstellar medium is often described as a vacuum, but to the craft, it is a soup. It is a thin, electrified gas of ions and electrons. To measure this soup, Voyager 1 uses its plasma wave science instrument. Because the craft's dedicated plasma detector failed decades ago, the engineers had to get creative. They began to listen to the vibrations of the space through which the craft was moving. When the sun has a massive eruption, it sends a shockwave through the solar system. Even though Voyager is outside the bubble, that shockwave eventually hits the interstellar plasma, causing it to ring like a bell. This ringing happens at a specific frequency called the plasma frequency. The physics is elegant. The frequency of the vibration is directly proportional to the square root of the electron density. By measuring the pitch of this cosmic hum, we can calculate exactly how thick the soup is. In 2013, the craft heard a high-pitched whistle. It was the sound of the interstellar medium being compressed by a solar storm. It was a haunting, ascending tone. It confirmed, beyond any doubt, that the craft was in a dense, alien environment. The soup is made of hydrogen and helium, salted with traces of heavier elements like carbon and oxygen. The density is incredibly low, about 0.1 atoms per cubic centimeter. On Earth, a cubic centimeter of air contains quintillions of atoms. But in the void, even this tiny amount of matter is enough to create a weather system. There are interstellar clouds. There are ribbons of magnetic force. There are voids within the void. Voyager 1 is moving through a region known as the local interstellar cloud. It is a wispy nebula about 30 light-years across. We are moving through a warm patch of the galaxy, where the temperature is about 6,000 degrees Celsius. This sounds hot, but because the density is so low, there's no heat to feel. A single atom is moving very fast, but there are so few of them, they cannot transfer their energy to the craft. Voyager records the persistent hum of this plasma. It is a low-level, constant vibration. It is the sound of the universe's baseline. The spectroscopy of this region shows a dominance of neutral interstellar gas. This gas is unionized. It hasn't had its electrons stripped away by the sun's radiation. This means it can drift through the magnetic fields of the galaxy without being diverted. Voyager 1 is observing the interactions between this neutral gas and the charged plasma. It is a study in fluid dynamics on a scale of trillions of miles. As the craft moves, it leaves a tiny, invisible wake behind it. Because it is moving at 38,000 miles per hour, it is technically supersonic relative to the interstellar gas. This creates a tiny bow wave effect, a miniature version of the ship's wake in water. The craft is a disruption in a sea that has been still for millions of years. It is a tiny needle of earth metal threading through a fabric of galactic ions. The soup is ancient, the soup is cold, and Voyager is the only one there to taste it. Deep inside the hull of Voyager 1 lie the radioisotope thermoelectric generators, or RTGs. These are the craft's lifeblood. They are not nuclear reactors. There is no fission, no splitting of atoms in a controlled chain reaction. Instead, they are much simpler. They are small furnaces. Inside each of the 3 RTGs are pellets of plutonium-238 oxide. This specific isotope of plutonium is not used for bombs. It is used for heat. As the plutonium atoms naturally decay, they emit alpha particles. These particles are heavy and move with great energy, but they are stopped almost immediately by the surrounding material. When the alpha particle is stopped, its kinetic energy is converted into heat. The pellets of plutonium glow with a dull cherry red heat, reaching temperatures of over 1,000 degrees Celsius. This heat is the only thing keeping the craft alive. The external temperature of space is near absolute zero, minus 273 degrees Celsius. But inside Voyager, the radioactive heart is beating with a warm, steady pulse. This heat is converted into electricity using a phenomenon called the Seebeck effect. The Seebeck effect is a cornerstone of thermodynamics. When you take two different metals and join them together at two different temperatures, an electrical voltage is created. In the RTGs, thousands of these junctions, called thermocouples, are wrapped around the hot plutonium. One end of the thermocouple is pressed against the hot core. The other end is connected to a radiator that faces the cold of space. The temperature difference drives electrons through the circuit. There are no moving parts, no turbines, no pistons, just the silent, steady flow of electrons, born from the difference between the warmth of a decaying atom and the chill of the infinite dark. But the pulse is slowing. Plutonium-238 has a half-life of 87.7 years. This means that every second, a few more atoms have finished their decay and turned into stable uranium. The heat is fading. Every year, the RTGs produce about 4 watts less power. This is the death of the machine. To survive, Voyager has had to make hard choices. One by one, the heaters have been turned off. The cameras were the first to go, then the heaters for the various sensors. The craft is now operating in a state of deep hypothermia. Its internal components are functioning at temperatures far below what they were designed for, yet they continue to hum. The color of this process is the color of cooling embers. At launch, the RTGs provided 470 watts of power, enough to run a large microwave. Today, they provide barely 230 watts. That is less than 3 standard light bulbs. This meager energy must power the computer, the radio, and the remaining scientific instruments. Voyager is a minimalist now. It spends its energy carefully, like a man in a blizzard husbanding his last matches. The thermodynamics are relentless. Eventually, the temperature difference between the core and the radiators will be too small to generate a usable voltage. The pulse will stop. The electrons will cease their flow. And Voyager 1 will become a cold, silent monument of gold and aluminum, drifting forever in the soup of the stars. On February 14th, 1990, Voyager 1 turned its narrow-angle camera back toward the center of the solar system. It was 3.7 billion miles away, a distance so vast that the sun appeared only as a brilliant, blinding point of light. Voyager was commanded to take a series of 60 images, a family portrait of our planetary neighborhood. In one of these frames, a tiny sapphire speck appeared. This is the famous pale blue dot. To the camera's charge-coupled device, the Earth was not even a full pixel. It was a fraction of a light sight, a ghost in the machine, caught in a scattered beam of sunlight. The color of that dot is a specific, haunting shade of blue. This is the result of Rayleigh scattering. As sunlight enters the Earth's atmosphere, it strikes molecules of nitrogen and oxygen. The shorter blue wavelengths of light are scattered in every direction, while the longer, red wavelengths pass through more easily. From the perspective of Voyager 1, looking back through the immense vacuum, that scattered blue light is all that remains. It is a fragile color. It is the color of a planet that is mostly water and air, wrapped in a thin, translucent veil of gas. The camera's lens, with a focal length of 1,500 millimeters, struggled to resolve it against the glare. The sun's light reflected off the camera's internal housing, creating the famous sunbeams that appear to cradle the Earth. There is a profound loneliness in the geometry of this image. The Earth is suspended in a vast, velvet void. It is a grain of dust in a cathedral of shadow. The physics of the image are simple. Photons hitting a silicon wafer. But the weight of it is immense. Every human who has ever lived, every war ever fought, every discovery ever made, happened on that subpixel. Voyager felt the camera shutter click for the last time. This was the final visual act. After this, the cameras were powered down to save energy for the journey into the dark. The craft became blind, no longer looking back, no longer looking ahead. It began to rely entirely on its touch, its magnetic sense, its silent, internal clocks. The transition from a visual mission to a sensory one is a slow, quiet process. Voyager no longer sees the rings of Saturn or the clouds of Jupiter. It sees only the telemetry. It sees the flux of magnetic fields and the density of the plasma. The darkness of the void is not a lack of information. It is a different kind of information. It is the information of the background. The craft is moving through the ecliptic, but it is also moving through time. Each bit of data sent back to Earth takes hours to arrive, traveling at the speed of light, growing weaker with every mile. We are listening to a heartbeat from the past, a blue echo in a black room. The brain of Voyager 1 is a relic. It is composed of 3 redundant computer systems designed in the mid-1970s. The flight data subsystem has a total memory of about 68 kilobytes. To put this in perspective, a modern smartphone has millions of times more memory in a single icon. This is a computer made of discrete components, transistors, resistors, and magnetic core memory. The memory is physical. It consists of tiny ferrite rings or cores woven together by fine wires. Each ring holds a single bit of information, represented by the direction of its magnetic alignment. This memory is remarkably robust. Unlike modern flash memory, which can be corrupted by a single stray cosmic ray, magnetic core memory is hardened by its very nature. It is a physical, mechanical state. However, the radiation of deep space is relentless. High-energy protons can still cause bit flips, where a 0 becomes a 1, or a 1 becomes a 0. Voyager must constantly check the parity of its data, ensuring that the code that governs its flight remains intact. The spectroscopy of this digital environment is not light-based, but electronic. It is the flow of millivolts through gold-plated circuits, the steady hum of a 16-bit processor performing the same calculations for nearly half a century. As the power from the RTGs fades, the computer must work harder to manage its resources. The software has been patched from Earth, sent via the deep space network. These patches are like whispers sent across a canyon. They are tiny fragments of logic, transmitted at 160 bits per second, designed to bypass failing circuits and optimize the remaining sensors. There is a digital ghost in the machine, remnants of old code, instructions for instruments that were turned off decades ago, still sitting in the magnetic cores, waiting for a command that will never come. It is a museum of 20th century engineering, drifting through a 21st century void. The craft's communication system uses a high-gain antenna, a 12-foot wide dish made of aluminum honeycomb. This dish must be pointed precisely at Earth. Even a fraction of a degree of error will cause the signal to miss our planet entirely. The physics of this alignment is governed by the attitude and articulation control subsystem. It uses tiny bursts of hydrazine gas to rotate the craft, keeping the beam locked on a home it can no longer see. The hydrazine is cold. The valves are ancient, but they work. They click and hiss in the silence, a mechanical rhythm that keeps the conversation alive. Eventually, the signal will become too weak to be heard. The inverse square law dictates that as the distance doubles, the signal strength drops to 1/4. We are reaching the limit of our technology. One day, Voyager will send its last packet of data. It will be a final measurement of the interstellar plasma, a final check of the plutonium heat, and then nothing. The computer will keep running. The magnetic cores will keep their alignment, but there will be no one left to listen. The digital ghost will continue its journey in silence, a library with no readers, a mind with no voice. Voyager 1 is not headed toward a specific star, but it is moving in the general direction of the star Gliese 445 in the constellation of Camelopardalis. It will take approximately 40,000 years for the craft to pass within 1.6 light years of this star. This is a journey that defies human comprehension. In 40,000 years, the Earth will have moved through new ice ages. The stars themselves will have shifted their positions in the sky. But for Voyager, the journey is one of absolute stillness. There is no air to slow it down. There is no gravity to divert it. It is in a state of pure inertial motion. The craft is currently crossing the inner edge of the Oort cloud. This is a gargantuan spherical shell of icy objects that surrounds our solar system. It is the graveyard of comets. The distances here are so large that it will take Voyager 1 another 300 years just to reach the inner edge, and perhaps 30,000 years to exit the other side. The Oort cloud is the final boundary of the sun's gravitational influence. Out here, Voyager is truly weightless. The pull of the sun is almost indistinguishable from the pull of the other stars. The craft is drifting in the interstellar tides, a leaf on a dark, cosmic ocean. The silence is now complete. The RTGs have cooled. The computer has gone dark. Voyager is no longer a machine, but a geological artifact. It is a piece of Earth crust that has been shaped by human hands and flung into the deep. The gold disk on its side remains, its atomic structure stable, its message intact. The spectroscopy of this future is a study in black. There is no reflected light. There's only the faint, distant shimmer of the Milky Way, a band of light composed of 400 billion suns. The craft is a tiny, dark speck against this brilliance, a shadow moving through a forest of light. Close your eyes now. Feel the weightlessness of the craft. There is no up. There is no down. There's only the forward motion, the steady, unchanging velocity of 17 kilometers per second. The cold of the void is not a threat, it is a blanket. It is the ultimate preservation. Voyager is at rest. It has finished its work. It has crossed the boundaries. It has seen the giants and felt the shock of the wind. Now, it simply is. The stars are far apart. The gaps between them are millions of miles of nothingness. You are drifting into one of those gaps. The light of the sun is now just another star, indistinguishable from the rest. The heartbeat of the woman on the golden record is still there, etched in gold, vibrating at the frequency of the atoms. It is a heartbeat for the universe. It is a heartbeat for you. Let your own breath slow to match the rhythm of the drift. The long, 40,000-year sleep has begun. The vacuum is soft. The dark is kind. We are drifting now. We are drifting forever.